Digital electronics, the Nand gate latch. Hello everyone. In this video, I would like to invite you for a conversation about the Nand gate latch. Observe that the Nand gate latch is composed of two cross-coupled Nand gates, where the output of one is connected to the input of the other. For example, observe that the output of NAND gate 1 is connected to the input of NAND gate 2, and the output of NAND gate 2 is connected to the input of NAND gate 1. Observe also that the outputs Q and Q bar are complementary to each other, which means that whenever Q is 1, Q bar is 0, and whenever Q is 0, Q bar is 1. Else, the NAND gate latch has two inputs, set and reset. The set input sets the output to 1, and the reset input resets the output Q to 0. Now, let's observe what happens to the output when the different possibilities for the inputs are applied. The first possibility is when both set and reset are 1. And here we have two alternatives. Firstly, when Q is 0 and Q bar 1. This 0 here will flow to the input of NAND gate 2. And 0 and 1 as inputs to a NAND gate produces 1 at the output. This one will flow here, 1 and 1 as inputs of an AND gate produce a 0. Then the initial condition is preserved. Now let's see the opposite when Q is 1 and Q bar 0. Okay? This one here will flow to NAND gate 2, and 1 and 1 as inputs of an AND gate produce 0, and this 0 will flow to this NAND gate 1, 0 and 1 as inputs of an AND gate produce 1. Then we see that when set and reset are above 1, the output is not changed. Alright, now let's consider the other possibility. When set is 0 and when reset is 1. When set is 0, the low logic level will prevail and produce a 1 here. This 1 will flow here to the input of NAND gate 2 and will produce a 0 here. Alright? Then when set is 0, Q is 1 and Q bar is 0. The other possibility is when set is 1 and reset is 0. Regardless of this value here, 0 at an AND gate will prevail and produce a 1 at the output. This 1 will flow here, 1 and 1 as inputs to an AND gate will produce a 0 here. This 0 will come here and produce a 1 again. Then this is the situation, okay? Whenever the set input is 1 and the reset input is 0, the output will be 0, okay? The output is 0. And the last possibility is when both set and reset are 0. This produces an invalid situation because the outputs are unpredictable. Okay, now let's set the latch. At first, both are 1. The reset pin is 1 and the set pin is 1, fluctuates to 0 and then becomes 1 again. What is going to happen to the output? If the output is low and the Q bar is high, the output is going to see that here we are setting it to 1, okay? When set is 0, the output is 1. Then we are going to set it to 1. And the complementary Q bar will change from 1 to 0. We are applying a logic level 0 here to set the output as 1. And the opposite, resetting the latch, would be the opposite. Let's reset the latch. To reset the latch, S has to be 1, and here we are going to have a fluctuation from the logical level high to the logical level low, okay? And when this happens, when the reset is low, the output is low too, okay? And what's going to happen is that initially the output is high, and due to this pulse here, the output is going to change to low. And the Q bar is going to be the opposite. Initially it is low, and then due to this pulse here, it becomes high. Alright, my friends, this is the video that I wanted to make about the NAND gate latch. I hope you guys enjoyed it and learned from it. I am a teacher. If you want to book a lesson with me, use my WhatsApp number, guys. Goodbye!